Hello. In this session, we'll be looking at the project website that we have developed for this course. And we'll also look at how to process one of the datasets, one of the very important constituency datasets that we'll be using for the analysis. So the first page you see on this website is the overview. Now this page contains links to all the analysis that we'll be doing using this dataset. It also contains links to the datasets that we are using in this analysis. So mostly we'll be working with the datasets from the Election Commission of India. The link is here. So all the links to resources such as datasets, scripts, documents, reports, etc. that we'll be using in this analysis are present in the repo. The kind of analysis we can do or we will do, you can see are also listed here, and there can be a lot more. And there are also references to a few books that we have used for the analysis. The other important section of this website is the setup page. Now it's always a good thing to do, especially whenever you are following a session or you are following a project. It's good if you can reproduce everything on your local machine. So the setup instructions that we have here will help you to reproduce this entire project in your local machine or your local setup. The kind of packages that we are using for this course are also listed here, and you can use this function to download or install all the packages in one go. Now, the other important thing or the main objective of this session is to process a dataset or process a constituency dataset. We also have a process page where you can follow the instructions to process a dataset. Now, we'll look at what this dataset is about and how to go about the processing. But I'm just first explaining you how the website is structured. So let's just start with now, because we are at the processing page. So let's just start with, okay, what are we even doing in this course? What are the kind of data sets we'll be using? How to process it? Where are we trying to reach, etc., etc. So let's just start with point number 1, which is listed here, which says, or let me also zoom in a bit so that it's clearer. So the first thing, obviously, whenever you start processing a data set, is you first download the data set, or you first look at how the raw data is looking like. So first just look at, there are two important data sets that we'll be using. First is the constituency data, second is the candidate data. So first just look at what the constituency data looks like. And if you can see, if you click on any of this will take you to the raw data set, in this case, which is the Election Commission of India's website. So I have already opened a page. So this is the page for the constituency data summary report. Now this basically contains a data summary for all the 543 constituencies. So let's just look at how the structure of this data set. So if I click on download the file, so there are two options. The first one is I can download a PDF, and the second one is I can download an XLS file. So I have already downloaded both these files. So first just look at how to look at the basic structure of the website. It's good to open it as a PDF, and we already have a PDF downloaded. So let's just look at how this dataset looks like. So as you can see, since by the name itself, this is a constituency data summary, which means that it contains summary for all the constituencies that were a part of the parliamentary elections of 2019, and there were 543 constituencies. So let's just look at what the kind of variables that we have here. So the first constituency, and we can take it as a sample, is Aruku. It is an ST constituency. Now the variables are, you have the total number of candidates, total male candidates, total female candidates. You also have the total number of electors, disaggregated by gender. Similarly, you have the total number of voters disaggregated by gender. And you have the total number of votes. Now the difference between an elector and a voter is, elector is the total people who are eligible to vote, whereas voters is people who actually voted. So electors will always be more than voters. Going down, we can also see that we also have the valid postal votes or total valid votes polled, or votes that were polled from the voting machine. So those numbers are also available. And then very important, you have the date on which the election took place, date on which the counting took place, and date on which the result was declared. And finally, the final section of this of the constituency data summary, for each constituency you will have the result section, where you will see who the winner was, who the runner up was, and the margin of votes. The winning margin. You will also have the name of the candidate who won the election and the runner up's name as well. So it looks like there are a lot of important variables in the sheet. And another interesting thing to look at, if I go to another constituency, which is in this case Sri Kakulam, and it's a general constituency. So here you see that for all the constituencies, the data is structured in an exactly similar way. Like there is no difference. Each variable is where it was. Let's say for the first constituency, you will have the candidate name, the number of electors, the number of voters, the total number of votes, the candidates, the dates of polling, and the result. So these are all the five to six sections that are present for each constituency. Now, you might ask now how we will process this PDF. Now, before we start processing the PDF, let's also look at what is the structure of the Excel file we have. So I've already downloaded this Excel file. Now looking at it, it's a bit different from the PDF that we just saw. And obviously because here you will, an Excel file gives you more flexibility to curate data or store data. So here you can see the first row. So the first important thing you will see here is the PDF was, every constituency had a couple of pages. Here every constituency has one sheet. So if I right click on this small arrow that you see, so I can see, so this gives me a list of all the 543 sheets that are part of this Excel file. So SO11, SO12, S stands for state. So how you read this is, for the first state, this is the first constituency, sheet number 1 or constituency number 1. Similarly for first state, this is constituency number 2. So this is how the data is structured in the Excel file. So before you begin data processing, it's very important to understand how the Excel file is structured. So basically how this is structured is you have one sheet for each constituency. So which means you have in total 543 sheets. And another pattern you will notice here is if I go from S01-1 to S01-2, I can see that the structure of the file is not changing. The numbers are changing, but the structure of the file is not changing. If you observe here, if I go alternate between these sheets, only the numbers are changing, the structure is not changing, which is a very important thing to notice because it gives us a clue to how to process this data set. If I am looking at the sheet for the first time, what I will do is I will try and write the code to process data for just one sheet, and then I will see if the code can be, if I can run the same code for all the 543 sheets. That saves me so much of time. Imagine that if I am manually entering this data in a database, now I will have to enter data for 543 sheets, but here I will just write code for one sheet and run the same code for 543 sheets. Now this is important because the structure is not changing, only the number is changing. All right, so now let's let's look at how we will process these 543 sheets. But again, before we do that, it's also important to check where are we trying to reach, because when we look at the code, it will help us visualize it's important to visualize the final structure of where do we want to reach when we are writing the code. And since we have already written this code, since we have the final results with us, so it's easier to visualize in this case. So this is how the final sheet looks like. So as you can see, you have so this says 544 lines. The first line is for the header. So it basically means this data is for 543 constituencies. There are 543 rows. So from 543 sheets, you are reaching to 543 rows. This is where we want to reach. And as you can see, all the variables that were present in different rows of the Excel file have been converted to columns. So whatever variable we need have been converted to columns. So you can see that there are close to 70 or 80 columns present in this in this file, or maybe less. This is the final version, but the idea is to convert the Excel sheet into this into one file, which can be stored as a CSV file, a very simple comma separated value file. So now let's look at the code. So I'm again going back to the data processing guide, and here you will find the link to the code. So if you read step number 2, it says please refer to the file to follow the steps to process data for each constituency. Now if I open this file, if I click on this file, you will land here. Now let me just zoom in this page a bit. So this code is on GitHub, which is because this is an open repository. You can read the code. You can also clone this repository in your local machine and run this code. So you will find all the links in the project website. So you can, the way we will do this, we will read the code. We will first understand the code using GitHub, and we will also try to see how we have structured this code here. So the first thing we are doing is we are sourcing all the libraries. Now let me also open our R console just so that we can see how we can run this code as well. So this is our R console, and we have the same code that you saw here. The same code is here. We have opened the same file in RStudio. So the first thing you see is first we are sourcing all the libraries. Now why is this required, or why is this needed? Now for every R project, it's very important to have a list of libraries at one place, so that anyone who is then reproducing your code, they know what are the kind of libraries you're using, and they can install all the libraries at once. So if I go to this file, which is source libraries.r, I go here, this file is present in the code directory, as you can see, and this is the file that I have created. So you can see the list of all the libraries that we are using for this session or for the project. And here what we are doing is we are sourcing all the libraries at once. So if I just run this line, so this will load all the libraries that we are using in the project, and I have access to now all the functions within these libraries. So as I told you before, I have already downloaded the raw Excel sheet here. So this is the path to the raw sheet. Now, because I have created this project, I don't have to mention the entire path. I can mention the relative path, which is where the raw data file is. So the raw data file is stored within the data directory. There is another raw directory inside the data directory, and then you have the Excel file. So I have listed the path here. Now this is just the function I'm using here is to because it's an Excel file. An Excel file can have multiple sheets. So just to make sure that I have access to all the sheets, or the total number of sheets that are present in this file, I'm using this function called Excel sheets. Now if I run this function, which is from the read Excel package, if I run this function and if I look at the output of this function, you will see there are 543 sheets available, because there are 543 entries inside this vector, all underscore sheets, or variables inside this vector. So this basically means that the Excel file has 543 sheets. Now, as I mentioned before, how we are going about processing this data is we will write code to process one sheet, and then we will run that code for 543 sheets. That is our basic process to process this data. So I'm creating a function here. Now the need to create a function is because I have to run this function multiple times. So that is why it's better to create a function and then just write some sort of a loop that runs this function multiple times. So I have created this function get underscore sheet underscore data. Now let's just try and look what is this function doing. So the first thing is that I'm just printing the name of the sheet, because imagine if I'm running this function again and again, this statement will help me see, okay, which sheet is getting processed. So that is the use of this print function. Now the most important thing inside this function is how you read an Excel sheet. because reading a CSV file is very straightforward. There are read underscore CSV is the package or is the function that is inbuilt in R. But reading an Excel file can be a bit tricky sometimes because Excel is not an open format. It's a proprietary format, and then but fortunately there are packages inside R that will help you read an Excel file. So in this case, we are using the read Excel package. So there is the function read underscore Excel. Now this function can take multiple arguments. Here we are using two arguments. The first one is the sheet itself or the name of the sheet, and the second one is the path, which is the path to an Excel file. So you give the path to an Excel file and you give a sheet name, and that will read an Excel sheet for you. And then we are also converting this Excel sheet to a data frame. So this is how you read an Excel sheet. So once you have read a sheet, then you will, I'm again going back to the Excel sheet. So the way we are going about processing this code is, so let's say if I have to get the name of the state and the code of the state. Now I know that for every sheet, the name of the state is present in this cell, which is row number 2 and column number 2. Similarly, the constituency name is present in this cell. Similarly, male candidates and female candidates are present. So there is a fixed position to every variable. So the only thing we are trying to do here is, if you see, we have created these variables: state name, constituency name, number of polling stations, dates polling, etc. And then we know that where in this Excel file these variables are stored, in which cell. So we are just reading this variable directly from the location of those cells. So that is the logic that we are following for reading some of the variables here. So if you can see that we have also listed the rows for each data point. So candidate rows, elector rows, voter rows, and number of votes, because these are the 4 sections. If you see the Excel file again, so these are the 4 sections. So the candidate rows are here. This is what we mean by elector rows. This is what we mean by voter rows, and this is what we mean by votes rows. So that is how we are reading. So basically we are just taking sheet underscore row, which is our Excel sheet, and candidate rows. This is the number of rows that we are reading, and this is the column that we are reading. So row number and column number will define each cell, and that cell will, the value of that cell will be stored in this particular variable, which in this case is candidate calls. Candidate calls underscore value underscore men, which is basically total number of male candidates. So you will find we are following the same process for all other variables as well. So I will skip this part because this is so when you run this code, you will easily understand, you know, the kind of the way we are creating this data frame. And in the end, what we are doing is, we are just combining all these variables. In a data frame. So you see that this is all calls, and this is the list of all the calls that we are using, and then this is all the values. So imagine this is creating one entire row. So column name and then value, column name and then value. So this is how we are creating this data set. So before I run this for 543 sheets, it's also important to look at how an Excel sheet is read. So what I'll do here is I'll just run this for one sheet. So I'll first run this line to store the value of constituency master path. Then I'll probably copy this this line from here, go to my console, paste it here. Instead of sheet underscore, I'll just use a sample variable X. So I'm using read underscore Excel function, the sheet. Okay, so as you know, we have already stored if I look at the all sheets function, now all the sheets are stored here. So let me just run it for one of the sheets, which in this case SO1-1. So again, I'm copy pasting the Excel function. So instead of sheets, I'm using all underscore sheets, and I want to use the first value, and the path is constituency, master path, which is the path of the Excel file. And I'm saving this in the variable called X, and I'm converting this to a data frame. So if I click here, now because we are using dplyr and all the tidyverse set of packages here, I can use the function this way, which is I can use this magitar symbol and then run attach functions basically. All I can do in just one line instead of writing code again and again. So if I just click enter, and let me look at the structure of how so they're looking at the structure of this, so I can also use a view X. So this is how an Excel file is read. All right. So you can see here, this structure is very similar to what we had in the Excel file. So that is what will happen if you read one Excel file. Now let's look at what will happen. So this is the first function. So excuse me, this is the function that we have written to process data from one sheet. And now let's understand another important section of this code, which is how we will run this function for 543 sheets. So here we are again using something called as map_df, which here is a sort of a loop. What map_df does is it will take this function, which in this case is get_sheet_data, which is the name of the function, and it will take the other variables. This is the other variable which we need here. If you look at the function, we need two variables to process. The first one is the sheet name, and the second one is the path of the sheet. So going below, I know that I know this. So how I'm executing this is the first thing I'm doing is, so let me just copy this function to make it more easier for you to understand. So I'm copying it in my console here, and I'm just running the first part, which in this case is constituency master part, and then Excel sheet. So this will give me the list of all the Excel sheets that are present. So then I'm piping, so you can call it piping, you can call it attaching, whatever. Then I'm piping this list of Excel sheets to the map_df function, which will run get_sheet_data for all the 543 sheets. All right, so this is how this function runs. So if I run this function, so let me just try and run it for probably one or two sheets, so that you can also see the output that we get. So I'm using a head function so that I can use run this function for only two Excel sheets. So if I click on this and if I run the function, so let me just the function has executed, and let me now check how many rows and how many columns are there in the constituency master df. So there are 2 rows and 88 columns, and I can also look at the output here, constituency master df, and you can see that we have converted that ugly Excel output to a very structured output, and then you have all the variables that were present in the Excel sheet in this particular data frame. Now, since we have run this for 2, we can run this for n number of sheets. So I'm just removing this head from here, and so now if you run, this will run for 543 sheets. And finally what we are doing is we are just exporting this file as a CSV, and at the end what you will get, at the end you will get a file which is very similar to the file that we saw here. And here, because this is on GitHub, you can also search the name for your constituency. Because I am from Jabalpur, I will just search for Jabalpur, and this is you will get all the details of Jabalpur constituency in this file. All right, so let me just quickly summarize what all we did in this session. So the first thing we did was we went through the project website. Now this project website is an excellent resource for you because it has links to all the resources that we will use in this session, whether they are scripts, whether they are dataset, whether they are reports, etc. You will find the links to all the analysis that you will do in this file. Now there are a few important sections of this website. The first one being the setup, which will help you set this entire project up in your local machine. And the second one is the data processing guidebook, which will help you process the data. Now then we looked at the structure of the constituency dataset, and we also looked at the PDF file, and we created a framework where we wanted to reach, which is uh, we wanted to process this PDF constituency summary data for 543 constituencies, so that we create a file which has 543 rows, and then we looked at the code that will help us do it. In the code itself, we looked at two important things. The first one being how you read an Excel file, and the second one being how you can use the map_df function from the tidyverse set of packages. The name of the package here is purrr, which is purrr, which you can use to run this function. Now you may ask, there are other ways also to run a loop. A very simple way to run this loop can be a for loop. So basically you write a function and then you execute a for loop 543 times. That is one way. The other way, which is kind of inbuilt in R, without, you don't have to use any packages, is you can also use the apply family of functions, or you can use to be more specific, you can use lapply. Now you will use lapply in a very similar way, and let me quickly show you the syntax for that as well. So you will write lapply and you will write the list, which in this case is all the Excel sheets. So instead of map_df that you see here, you will just use lapply. So let me just comment this out, and you will use lapply, and you will use you don't have to write the list name because it's already loaded. The function you will use is get_sheet_data. You don't have to use path because we are using the same path. The Excel path is not changing. But if you have to use, you can just copy paste this line, and this is another alternate of map_df. But since we would like to use the tidyverse set of functions, and also this is a small data set, but in larger data sets you will also notice an improvement in the execution time as well, especially if you use some of the tidyverse set of functions, but that really depends on the context. In this case it won't matter because we are working with a small data set. So I hope you found this useful. In the next session we'll continue exploring this data set further. Thank you.